On the same side of a straight river are two towns. And the townspeople want to build a pumping station S that supplies water to them. The pumping station is to be at the river's edge, with pipe extending straight to the two towns. The distances are shown here in this figure. We'd like to know where the pumping station should be in order to minimize the total length of the pipe. Well, we have a picture here. This X represents this distance there on the river. Mark it in red, that distance right there. And we are trying to minimize the distance of the pipe. So that right there. Well, that is, those two things are hypotenuses of triangles. And so we can go ahead and just use the Pythagorean theorem to label those. Let me first just point out that if this distance right here is x, then the distance here is going to be 4 minus x, because that's this distance along the river. And of course, we've got 1 there and 4 there. So this distance here, by the Pythagorean theorem, is the square root of x squared plus 1. And this distance right here, again by the Pythagorean theorem, is the square root of 4 minus x squared plus 4 squared, which is 16. And we just add those two things together. So the total distance, L, as a function of x, is the sum of those two things. So the square root of x squared plus 1 plus the square root of, and then I'm going to go ahead and multiply this out. We've got an x squared. We've got a minus 8x, and then we've got plus 16 plus another 16, so plus 32. Okay, that's our function, our length for the length as a function of x. And we're trying to find the minimum length, and so we're going to take the derivative of this. So L prime of x. Well, if we think of a square root as a power of 1/2, we get 1/2 x squared plus 1 to the negative 1/2, and then by the chain rule times 2x. And then over here, same idea, we have the 1/2 times x squared minus 8x plus 32 to the negative 1/2, and then again by the chain rule times the 2x minus 8. All right, I am going to simplify what I can here. The 1/2 and the 2 will cancel. This 1/2 will reduce this to an x minus 4. And then I'm going to write these as fractions. So I've got an x, this x over the x squared plus 1 to the 1/2. And then plus, here we've got, again, x over, x minus 4. X minus 4 over x squared minus 8x plus 32, again to the 1/2. Now, we are looking for when this derivative is equal to 0, because we're looking for critical numbers. So we'll set this equal to 0. And now we want to solve for x. I'm going to move this fraction to the other side. I'm going to subtract it from both sides. So this gives me x over x squared plus 1 to the 1/2 equals the negative of this, because I subtracted over, which ends up being 4 minus x on top, over the x squared minus 8x plus 32 to the 1/2. Okay, I want to point out real quick that that x is a positive value, and so is 4 minus x. Okay, clearly, I'm going to place the station here to minimize length of the pipe. It's going to be somewhere in between the two rivers. So these are both positive values. I'm going to go ahead and square both sides here to get rid of this 1/2 power. And that gives me an x squared over x squared plus 1 equals, now squaring 4 minus x gives me 16 minus 8x plus x squared, and then over that whole thing, x squared minus 8x plus 32. So I've just squared both sides of the equation, and I want to solve for x now. I'm going to go ahead and cross multiply here. And it's going to take a little bit of algebra to do that. So cross multiplying, I take x squared times all that down there. It gives me x to the 4th minus 8x cubed plus 32x squared. And then equals multiplying this thing by x squared plus 1. I'm going to go ahead and multiply it all by x squared first, and I'm going to rearrange the order here. So multiplying x squared by x squared gives me x to the 4th. And then minus 8x by x squared is minus 8x cubed. And then the 16x squared. And then the 1 times all of that, which is plus another x squared, minus 8x, and plus 16. All right, this is a fun polynomial to solve. Let's go ahead and move everything to one side because lots will cancel. If we subtract x squared from both sides, we see that it cancels. X to the 4th from both sides. And if we add 8x cubed from both sides, that's going to cancel as well. And let's go ahead and subtract. Actually, we'll move everything over here. We've got here a 17x squared that we'll subtract over. That gives me a 15x squared. And then add the 8x, so plus 8x. And then minus 16. And this equals 0. And our goal here is to solve for x. And if we could try to factor this, but it doesn't really matter. We don't have to go through that process. We can just use the quadratic formula. So we'll do x equals negative 8 plus or minus the square root of 8 squared minus 4 times 15 times negative 16 all over 2 times 15. Now, this gives us two options, negative 8 plus that or minus that, but the minus is a negative number, and x, of course, cannot be negative because it represents how far down this distance, and so it's going to be the positive. So that gives us a negative 8 plus the square root of 8 squared is 64, and then minus a negative, so plus, let's see, 4 times 15 is 60, and 6 times 16 is 96, so this is 960, all over 30. Okay, and then 64 plus 960 is 1024, and that, super convenient, happens to be a perfect square. So we get negative 8. This is 32 squared. So this is 32 over 30. Okay, negative 8 plus 32 is 24. 24 over 30. Okay, so we get 4/5 or 0.8. I'm just going to leave it as 4/5. Okay, that is our value for x. That's our only critical number. Let's go ahead and double check. It is going to be the minimum, but we'll go ahead and show that. So this was L prime. We'll create a number line, a sign chart, 4/5. If we plug in 0 for x into our derivative, this is 0, and this is a negative, negative 4 over 32 to the 1/2. So this is a negative number. So our derivative over here is negative, meaning the function's decreasing. And if we plug in a number bigger than 4/5, let's plug in 4. This is 0, and we get 4 over square root of 17. That's a positive number. And so our function is decreasing and then increasing, so we have a relative minimum at 4/5. So we know that critical number does give us the minimum that we're looking for. So to minimize the total length of pipes, the pumping station should be located 4/5 of a mile down from town 1.